The remaining wiring consists of digital inputs to the controller, such as status read, and digital outputs from the computer, such as gate 1, gate 2, and computer fail. Much of the wiring is common to one whole 5-pack. Examples are status excite, gate 2, and update. Update is actually an analog signal. The computer fail relay is a digital signal commanded by the computer and sensed by the controller. This controller uses CFR 2.5. The computer fail relays are located in cubicle P1. This is relay 2. This portion of the control loop can be engineered many different ways, so we won't dwell upon these signals. The operation of the signals is explained in the previous lesson. The remaining wiring does follow the same format as the rest of the loop. That is, use the loop diagram until you need supplementary information. For instance, the loop diagram tells you status read is a green wire. This means little if you want to find the wire so you can test and terminate it. A status sense wiring detail and schedule should be used. A matrix gating jumper schedule should be used to complete the gate 1 line. The computer gating block wiring diagram should also be used. And a computer fail relay drawing should be used to wire the CFR circuit. The computer inputs and outputs cannot be grounded for continuity checks. What would happen if you grounded the update line in an effort to continuity check? The update line is common to all the controllers serviced by a particular computer, so the computer output to all the controllers will go to 0. This could cause a gigantic process upset. Status excite is plus 36 volts. If you ground it, an internal computer fuse will operate. This will make the computer think all the controllers in a 5-pack are on backup control. It will not service the controllers. Complete the remaining wiring. Always test the computer wiring for continuity before you terminate it. Make sure the jumpers on the back of the controller are in place. Mark all the wiring you have tested and completed. The loop is now complete. It is ready for checkout, synchronization, and commissioning. The loop specimen used in this lesson is for a specific control center. However, the approach to installation and checkout is similar throughout the industry. The approach used will fit any and all loop installations. For any loop installation, a loop diagram plus supplementary information is needed. The installer must have a basic knowledge of wire terminating and testing, and he must be able to interpret engineering information. This lesson will be concluded by a skills lab. Your instructor will detail the instrument loop particulars used in your plant. Now work exercises 9 and 10 in your workbook.